1976 V8 charging system for AMC cars and Jeep vehicles uses a motorcraft alternator and voltage regulator. This system is wired somewhat differently than Delco or Motorola, and this wiring diagram is explained in detail in your film review booklet. However, the charging system components are the same as for other systems: the alternator, drive belt, regulator, battery, wiring cables and harness, and indicator light or ammeter. You'll find 40 amp and 60 amp alternators identified by stamped printing on the housing and colored paint surrounding the stamped figures. Both sizes are basically identical in construction and use the same regulator part number. The alternator, like current Delco models, is Y connected and produces a three-phase output, which is converted to direct current by the diodes in the rectifier plate. And from this exploded view, you can see the construction is similar to other alternators. A rear housing mounts the rear bearing, brush holder, and the rectifier assembly. The stator is wired to the rectifier by soldered connections, and the rotor and slip ring assembly turns in bearings in the two housings. The terminals at the rear are the stator neutral, battery, and field connected to the wiring harness. The ground terminal is connected to a separate black wire which assures a ground between the alternator and regulator. The regulator terminals, marked on the cover and connector, are I to the ignition switch and charge indicator light, A to the battery positive terminal, S to the stator neutral junction, and F to the field terminal of the alternator. Troubleshooting of the motorcraft charging system can usually be done with a voltmeter, ohmmeter, and jumper wire. It is helpful, however, to also have an ammeter and diode tester, which may be required. Be sure to approach troubleshooting by first defining the problem. Most problems will be one of three. 1, the indicator light stays on or the ammeter discharges. 2, the battery is low or dead. Or 3, the engine cranks slowly. And depending on the kind of problem, it can be in the wiring, it can be battery trouble, or it can be caused by the alternator or regulator. There are some preliminary checks to make before you start testing in the charging circuit. Take the battery first. On a slow cranking problem, always check the battery cables at both ends for good connections. They may simply need to be cleaned up from corrosion and tightened properly. Also, check if the cables are in good condition, free of damage. And look at the battery condition. Is the hold down good and tight? Is there any sign of damage to the case? Clean the case if it's dirty, since that could cause the battery to discharge. Check the battery electrolyte level and the specific gravity. All the cells should be at least 1.225 specific gravity and within 50 points of each other. Follow the recommended battery testing procedures on the test chart and replace the battery if it's defective. Remember that a battery with a dead cell will not allow the alternator to work correctly. On charging problems, inspect the alternator drive belt first. Is it tight and in good condition? Set the belt tension if necessary with a gauge. Look over the wiring harness and connectors to see if any wiring is broken, pinched, loose, or grounded. If the problem is that the indicator light doesn't come on with the engine stopped and ignition on, make an indicator prove-out test. Remove the regulator connector plug and jump the I terminal to ground at the battery negative post. Turn the ignition on, but don't start the engine. The light should come on. Be sure to leave the ignition on only momentarily, no more than 4 or 5 seconds. This will be long enough to see if the light comes on, and avoid the possibility of damage to the wiring. If the light comes on with the circuit grounded, it means it isn't grounding through the regulator. If it doesn't light, you need to replace the bulb or check and repair the circuit. To prove out the ammeter, if it seems to be inoperative, simply turn on the headlights with the ignition off. The meter will show discharge if it's operating and its circuit is okay. If the ammeter shows discharge with the engine running, check out the S circuit, which should energize the field relay coil. An open circuit would cause no charging, even if the alternator is good. To make the test, remove the regulator connector and check for battery voltage at its S terminal, with the ignition switch on and the engine not running. If the voltage is okay, the circuit is not completed through the regulator. If there's no voltage, check and repair the circuit up to the regulator. If the preliminary checks don't locate the problem, proceed with the charging system tests. You can make a quick check of the charging system by measuring the alternator output under load with a voltmeter, following the procedure on the chart. Connect a voltmeter across the battery terminals. Start the engine and put a light load on the system by turning the headlights on. Check the voltage reading at 1000 RPM. It should be somewhere between 13 and 15 volts. If it is, and the battery is charged, the charging system is okay. If the charging voltage is too high, overcharging, check the regulator ground. It may not be grounded properly. If it is grounded okay, you may have a harness problem. To check that, remove the regulator connector plug and repeat the charging voltage test. If the voltage stays high, there's a short in the wiring. But if it drops, your problem is a bad regulator, and the regulator is not repairable. If it tests defective, it must be replaced. If the charging voltage tests low in the quick check, the trouble can be the alternator, the regulator, or the wiring. To find out which, perform the regulator and harness isolation tests. Be sure to disconnect the regulator plug before making the isolation tests, or the regulator may be damaged. With the plug disconnected, check for voltage at the A terminal. Then, isolate the regulator by jumping the A terminal to the field terminal. The charging voltage should now increase. If it does increase, it could indicate a bad regulator. If not, the wiring harness may be the problem. To isolate the wiring harness, leave the connector off and jump the alternator battery terminal B to the field F. If the test is good now, check and repair the harness. If the isolation tests fail to produce an increased voltage output, the problem is most likely in the alternator. Remove the alternator for testing on the bench. To remove the alternator, disconnect the battery negative cable, then the alternator leads, before loosening and removing the attaching bolts. On the bench, there are 3 continuity tests you can make for preliminary diagnosis before disassembling the alternator. Use an ohmmeter for these tests. Calibrate it and set it for the ×10 range. Check the rectifier ground and positive diodes by reading resistance from terminal S to terminal B. You should read about 60 ohms one way and an open circuit or infinity with the leads reversed. If you read low both ways, there's a bad positive diode or grounded plate, or the battery terminal is grounded. An open circuit both ways means that the stator terminal connection is open. Make the stator ground and negative diode test the same way, but at the S and G terminals. Again, resistance both ways indicates a bad diode or grounded condition, and an open circuit both ways indicates an open connection. Make the field circuit open or ground test with the ohmmeter on the ×1 scale and the leads to F and G on the alternator. Spin the pulley and check for a resistance between 3.5 ohms and 250 ohms. A reading below 3.5 ohms resistance indicates a grounded positive brush, a grounded field terminal, or a bad rotor. Above 250 ohms, you have a worn or hung up brush, an open brush lead, or a bad rotor. Incidentally, these tests and what to look for from test indications are summarized in your film reference book. Depending on the results, you'll next want to test the rotor assembly, stator or rectifier, with the alternator disassembled. To disassemble the alternator, scribe an alignment mark on the two housings for reference at assembly, and then remove the through bolts to separate the housings. Remove the terminal nuts and insulators to separate the rear housing and brush holder from the rectifier diode plate. Remember where each insulator goes. Pull the rectifier and stator assembly, which are soldered together at the stator coil leads, away from the rear housing. Unsolder the leads, and you're ready to perform the final bench tests. Again, remember where insulators are located. First, the rotor continuity test. Check for 3.5 to 4.5 ohms resistance from slip ring to slip ring. If it tests in this range, the rotor is okay. Below 3.5 ohms, there's a shorted wire or slip ring. Above 4.5 ohms, there's a broken wire or poor soldering at one of the slip rings. Also, check for rotor grounding with one probe at the shaft and the other to each slip ring in turn. You should read an open circuit. Any continuity, even with very high resistance, indicates a grounded circuit. Check the soldered connections to be sure they aren't grounded. If the rotor tests bad, install a new rotor assembly. Perform a stator continuity test with the probes between two leads, and then move one probe to the third wire and read the resistance again. If the resistance is equal between each pair of leads, okay. If not, the stator may be open. If the open is at the neutral junction, you may be able to repair it. Otherwise, replace the stator. Also, test each of the stator leads for grounding to the core and replace the stator if any of the coils are grounded. Finally, the diode tests. To make the negative diode test, the ohmmeter must be on the ×10 scale. Touch one probe to the ground terminal and the other to each of the stator wire terminals. Reverse the leads and repeat. Do the positive diode test the same way, but with the lead to the battery terminal. In each case, you should get about 60 ohms one way and an open circuit the other. If you don't, replace the rectifier assembly. So much for the tests. Now let's cover the rest of the alternator disassembly, inspection, and assembly. Remove the brush holder from the rear housing to check the brushes and also to retain them in the holder for assembly. Inspect the brushes thoroughly for wear, damage, and for good connections of the brush leads. If there's any problem, install new brushes. Check that the rotor assembly turns freely in the front housing bearing. If not, it must be removed for inspection of the bearing. To do this, Clamp the front housing in protective jaws in a vise and remove the pulley nut using special tool J21501. Then pull the lock washer, pulley, fan, and spacer to separate the rotor from the housing. Then remove the bearing retainer and inspect the bearing for damage and loss of lubricant. Check the rear bearing also. If either bearing needs replacement, support the housing in an arbor press to remove the old bearing and install the new one. Follow the technical service manual steps. Wipe all the parts clean with a dry cloth. Don't use solvent. And inspect for good solder connections and for damage of any kind. On the rotor assembly, be sure the slip rings are free of pitting and not damaged. Install the bearing spacer on the shaft with the recessed side toward the stop ring. Assemble the rotor and housing together. Then, the fan spacer, fan, pulley, lock washer, and nut. Tighten the nut to 60 to 100 foot-pounds torque. Next, assemble the brushes in the brush holder with a toothpick to hold them against their springs. Install the rear insulator over the field terminal screw and the toothpick. Install the holder in the housing with the ground terminal under one mounting screw and the toothpick and the field terminal through the holes in the housing. Press the holder out against the housing and tighten the screws securely. Solder the stator leads to the rectifier diode terminals with rosin core solder and install the alternator terminal screws, noise suppression capacitor, and insulators. Incidentally, with a stacked rectifier, there are two dished steel washers under the special screws, and you turn the screws a quarter of a turn to lock them in the rectifier. The flat rectifier has only one removable terminal screw and an insulator between the stator neutral lead eyelet and the rectifier. Don't use a steel washer here or the alternator will ground out. With the rear insulators in place, install the rear housing over the stator and rectifier. When the housing is in place, install the terminal insulators and nuts. Be sure the terminals seat properly as you tighten the nuts. Wipe the rotor shaft with a clean, lint-free cloth and assemble the two halves so the alignment marks register. Install the retaining through bolts. Tighten them securely and pull out the toothpick holding the brushes. Seal the hole with waterproof cement. Refer to your film reference book and to the technical service manual for additional details and specifications for the 1976 V8 charging system. Study the available materials. Troubleshoot carefully and systematically, and follow approved servicing procedures to give AMC and Jeep owners the best service in the industry.